Hey there, buddy. I see you're dying for a drink. What? You forgot to bring your wallet? Well, tough luck, buddy. You know what? Let me cut you a deal. Answer this question of mine and my best-selling drink is on the house. But if you can't solve it, it means you gotta pay up. And let me tell you, this drink of mine ain't cheap. Oh, don't be like that. Trust me, this drink is to die for. Perfect. Here is a coin and a coaster. The radius of the coaster is 3 times the radius of the coin. If the coin were to roll around the coaster once, how many revolutions does the coin take to go around the coaster?
In 1982, a similar question like this came out in America's SAT exam and every student got it wrong. The reason no one got it right was because none of the answers were correct and the actual answer was not one of the options. This question then became a mathematical paradox known as the coin rotation paradox. Logically, it should take 3 full rotations for the coin to roll around the coaster. If your intuitive answer was 3, I can tell you that the answer is wrong. A simpler version of this paradox can be seen with 2 identical coins. By our initial logic, this should rotate once. However, as you can see, this is not the case, as the coin has rotated not once, but twice. This is because the distance traveled by the center of the circle is equal to the amount the circle has rotated. If a circle is continuously rolling around the shape, the circle's center actually goes around the outside, increasing the distance traveled by, you guessed it, 1 circumference of the circle. So we have to find this distance and divide it by the circle's circumference to get how many rotations it has made. This goes the same way when the circle is rolling on a flat line. The circle travels along the line, making the travel distance of the center equal. And if the circle is rotating within a shape, the circle makes 1 less rotation. As modern technology and global coordination rely heavily on the accuracy of time, this principle is essential in astronomy for accurate timekeeping. This can be seen when we are counting 365.24 days in a year, which is how many rotations the Earth makes around the Sun in an orbit. But that counting is done from our perspective on Earth. To an observer from outer space, they instead will see that Earth did 1 extra rotation around the Sun. So while we count 365.24 days in a year, they will count 366.24 days in a year. This is known as a sidereal year. Sidereal means with respect to the stars, whereas solar means with respect to the Sun. The same concept applies to each rotation of the Earth too, where each sidereal day is 23 hours 56 minutes and 4 seconds, which is shorter than a solar day. This is important as all geostationary satellites that are built for communication and navigation uses sidereal time to maintain their orbits to sync with the Earth's rotation. This alignment ensures that the satellite remains fixed over the same point on the Earth's surface. For us on Earth, solar time governs daily life, whereas sidereal time is essential for space exploration and satellite communication. The answer is 4, you told the barista. He was impressed that someone managed to answer his trick question with such confidence he didn't hesitate to offer you his best-selling refreshment. Seems like thinking out the box sometimes does give us a new perspective on how we see the world, or in this case, looking out of the circle.